And we are live. Hello and welcome to another edition of my studying live streams. Today I will be doing more of analytic geometry. So without further ado, let's get into it. Nice. Pop this here. Let me find my problems. Go to the course site. Bang. Open this PDF. Bang. What the fuck? What the hell? They leaked their IP address. That's crazy. Was it 61 or something like that? No, that's trick. Oh, here. Distance here. What the fuck? Okay, this is actually good. Okay. So, today is going to be just problems, no theory. Because the theory, I don't know. I think I'll learn it just by doing this shit. Once again, the stylus not working, as usual. Okay. So, we have... Motherfucker. Okay. I'm sorry. I'm so sorry. No, that's not what I wanted to do. I don't understand why it can't just fucking work. Now it works. Okay. So we are looking for point B, which is I don't know how you say it in English. I'll draw a little picture to explain it. Minus 3, 2. Point A. We are looking for B. First, it has to be symmetrical along the x-axis, then along the y-axis, and then from the beginning. So that's pretty simple. For the result though. So x-axis. So you just you just turn this into negative and that's it. So b is going to be minus 3, minus 2 along y-axis. That's the same, but you reverse the second coordinate, the x coordinate, so it's going to be 3, 2. And that's going to be you reverse both. So going to be 3 minus 2. E.g. like here. I need to find the correct answers though. Are they at the end? 4, 4, 4, 4, 4, 1. Minus, minus. Yeah, okay. That's correct. Smart one is correct. And increment the streak. Okay. Next up. 4, 2. Distance of points. Oh, we'll not do. I'll just do 2, for example. For distance of excuse me. Here you are just calculating the Pythagorean triangle, basically. So you get the. What do you actually get? Just try to visualize it so I better understand it. B to my third. So we have -1, -2. A and B is -3, 0. We need to calculate this distance. So probably the easiest thing would be to take this, and then just calculate this basically. So we do B1 minus A1, so -3 plus, that's the length of this basically. It's 2. And then we do B2 minus A2. So that's once again the length of this, also 2. Which we have then the 2 sides, and we just calculate the third by the classic c squared is a squared plus b squared, or c is equal to this. Let me double check. -3 plus 1 is -2 squared, that's 4. 0 minus 2 is -2 squared, once again 4. 4 plus 4 is 8, which is square root of 2 to the power of 3, also known as 2 to the power of 3 halves. Let's do the second one. Well, let's quickly check. 2. Okay, so what they did is actually not this, but yeah, the solution stands anyway. They basically did 2 squared times 2, which is equal to 2 times this. Okay. Let's do the last one, for example. Oh, this is interesting. A here is, sorry, 2 and 2. And B is minus t and t. Minus t, t. So once again, distance of A to B is square root of B1 minus A1 squared plus B2 minus A2 squared. So that's equal to minus t minus 2 squared. Oh, I will probably need a little more space. T minus 2 also squared. We add a page. So that's fucking hell, bro. T squared minus 2, so that's plus 2t plus 4 plus t squared minus 2t plus 4, of course under the square root, and we end up with t squared, sorry, t squared plus 8 under the square root. Sorry, 2t. I could rewrite this somehow, but I don't know if it's beneficial. Is it? I don't know, the only thing that comes to mind is this is like 2 times t squared plus 8, sorry, plus 4, which can also be written as 2 times t plus 2 times t minus 2. However, I don't think this accomplishes anything. I will take a look at the results, but I think like this is as far as you can get. Yeah, that's the correct answer. But DJ Gollum, my man. Oui. Okay, let's go next. Uh, okay, so we have to check whether 4.3. I wanna look cool. Check if triangle has this 90-degree angle in there. A equals, sorry, they write it a little differently here for some reason, I don't know why. Because that's how we write vectors. This is how we write points, and they write it like you write vectors. Well, one way would be to do all the pointer vectors of the individual sections and then compare them to the normalized vectors. But I think there is isn't there like a rule that if you do A times B and it's equal to 0, that it's there is a 90-degree angle between them? I'll ask my good man Gemini. Wait. Yeah. Okay. So I have to get all the vectors from, so let's say AB, BC, CA. So this is B minus A, which is -1, -3, -4. 1 minus 4 is -3. This is C minus B, which is 0, that's 1, and you have to be careful here, bro. This is 4, and this is A minus C, so that's 3 minus 0, that's 3, 4 minus 4, -1. Let me just quickly double check. So B minus A, so that's -1, -3, that's -4, yeah. And 1, -4, -3, yeah. C minus B, 0 minus 1 is 1, 5, yeah, 4, and A minus C, 3 minus 0 is 3, 4 minus 5, yeah. And now we just have to do the scalar multiplication, which is -4 plus 1, so that's -4, -12 is obviously not 0. This is 3, -4, 1, and it's -12 plus 3 is minus 9. There are no right degree angles. I don't think I have to check between these, sorry. Between, I'll check them all. These two, and that all the, yeah, that's all probably. Check the results. No, okay. Let's do the other one to verify whether my course of action is correct. Ah, my nose, bro. It's itchy. Yeah, so A is 3, 5. B is 1, 1. And C is minus 3. Once again, vector AB, B minus A, which is 1 minus 3 is minus 2. 1 minus 5 is minus 4. Vector BC, C minus B, which is minus 3 minus 1, that's minus 4. And 3 minus 1, that's 2. This already looks very suspicious. Yeah, that is the right angle between these guys. So I don't even have to continue, because they are just asking whether there is a right angle. And also, I think if you have one right angle, if it's a triangle, then that's it. But to quickly verify, trust but verify. Okay. We have minus 8. Sorry. 8 minus 8. It's not really a right angle, is it? Nice. That's correct. Yeah. Okay. Let's go next. So that's all for like distances and shit. Now we are getting to the general equation of a line. Also known as linear equation. Oh, no, it's not. That's something different. Yeah, blah, 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 blah. Okay. So 4, 5. I can't even write. So as we know, that's ax plus by plus c is equal to 0. That's the general equation of the line. And I think you solve it by, well, 2 points. A 3 minus 1 and B 2, 4. You can either go through the route of first getting the parametric equation and then trying to remove the parameter, or you can get the normalized vector of these two, and this is the first element of the normalized vector, and this is the second element of the normalized vector. Then you input one of the points, and that gets you C. I wonder what is easier. I'll do it by the normalized route, because, so let's say this is b minus a, which is 2 minus 3 is minus 1, 4 minus minus 1 is 5. Sorry. Normalized vector is then 5, 1. And now we just take this and input it here. So we get 5x plus y plus c is equal to 0. Oh, can I type? Hello. And then we pop in what's going to be better. 3 minus 1 dot e. Okay, let's do this. So we get 15 minus 1 plus c is equal to 0, which yields that c is equal to minus 14. Oh, they went through the parametric stuff. What? What the hell? They write it so weirdly, bro. But wait, it's why? Yeah, yeah. So yeah, I forgot to write the whole equation, which basically, but it's correct. It's 5x plus y minus 14 is equal to 0. And they do it so weird, bro. But it's, yeah, you pop this here and here. It's 5x. Yeah, that's correct. You know what? I'll do the. I want to make a little change here to the text, because it's pissing me off. FF00 AA00 FF00 AA00. What the fuck? Okay. FF0000. Nice. So it's more visible. Yeah, so what I want to do now is actually do this problem once more, but try with the parametric uh, through the parametric equation. Let me just copy this over. What the hell? Bank. Nice. So as we already calculated, the pointer vector of this is b minus a, which is of course 2 minus 3, that's minus 1, and it's 5. And now we can just do the y equals minus 1. No. You put I think you put this here, if I remember correctly. So you put 3 minus t. And this is actually x, I'm retarded. And this is minus 1 plus 5t. Then we treat this as a system of equations, where we need to get rid of this t, obviously. So we just multiply by 5, which yields 5x is equal to 15 minus 5t. Y is equal to minus 1 plus 5t. And now we just sum them together, which yields 5x plus y is equal to 14. And now we just transfer the 14 to the other side, minus 14, and we get 5x plus y minus 14 is equal to 0. Once again correct, wow. And I will mark that down. Shameless? Maybe. Yeah, so let's go next. One more, and then I have to go piss. Okay, this is quite smart actually. So they want us to do for 6. Again, general equation of the line. We have point A, which is minus 3, 1. And point B, which is minus 5. No, what the fuck? No, minus 3, 7. Now immediately, what is very interesting is that the x for both point is the same. And since it's a line, not some complex function, minus 3, oh yeah. 1, 2, 3, 4, 5, 6, 7. 1, 7. This just means A, B. This is going to be the function, the line, sorry. So we don't even have to solve anything. And we can just say that x is minus 3, sorry, plus 3 is equal to 0. And this is the general equation, because there is no y. The y has literally no effect. I can even write it there. I can do x plus 0, y plus 3 is 0. But let's, just for practice, let's solve it. So let's get the pointer vector is b minus a, which is of course minus 3. So that's 0, and 7 minus 1 is 6. And then Yeah, and then the normalized vector of that is 6 and 0. And now we just input it into the equation. And now we need to get the C. So we just pop in, I don't know, this. So we get minus 18 plus 0 plus C is equal to 0, which yields that C is 18, which leaves us with 6x plus 0y plus 18 is equal to 0. Now we divide by 6, and we are left with x plus 0y plus 3 is 0. Same solution. So that's interesting that if you just look at the points and use your brain a little, which is not my strong suit, to be fair, using my brain is not my strong suit, definitely, we can just get away with not solving it, you know? Pretty cool. Okay, I do apologize, but I have to quickly use the restroom. Excuse me. Nice. Let's continue. Okay, let's continue. Uh, tu- 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 tu. Hmm. if they go into detail on the, whatever you wanna call it, directional form of the line equation, where you basically get where you work with angles, but to be honest, I don't want to do that. I hate working with angles. I suck. Maybe it will be good practice. Okay, so the k is the tangent of okay. Okay. So let's just quickly do it and maybe I'll remember it during the exam. So how you do this is you get y is kx plus q, where this k is the tangent of alpha, which is this here. It has to be the positive, like here, positive direction of the x-axis, and q is when the line intersects with the y-axis. So let's just quickly try to do some little problem. In French, un petit problème. So 4-7. Directional equation of two lines, P1 and P2. Both of them go through A. Which is 1 and 2. And P1 holds, wait, the angle of P1 is 3/4 of pi, also known as 135 degrees, and the angle of P2 is 1/3 of a, oh, I forgot how I write this. Pi thirds. So okay, I understand it now. Yeah, so first of all, let's solve for P1, where I need to find the k coefficient, which is going to be of 3 pi, which I don't know by heart because obviously it's not in the table. I have been rehearsing all this time. So I have to pull up a scientific calculator of 3 pi over 4. No way, man. Oh, it's in... Maybe I'm not supposed to do... I'm stupid, I'm not supposed to do... I just thought I'm supposed to do like... good old... tangent. Which... Oh, I actually do know this by heart. Oh, sorry. Because this is basically... hold on a minute. Yeah, this is minus 1/4 plus pi. And minus 1/4 is 1. So that's 1. So that's k. So we now have that y is equal k, sorry, x plus q. And I wonder if now I input the x and y values here, it actually spits out q? Yes or no? Minus 3. Yeah, I think so, yes. We'll just input it in here. 2 is equal to 1 plus q, which leads to q is 1. So that yields y is equal to x plus 1. Does that work out? Let's quickly pull up graphing calculator. Start calculator. Y is equal to x minus 1. Let's find the point. 1, 2. 1. What the hell? Yeah, that doesn't work out at all. It doesn't even go through that point. I guess I can't do it like that. That's a pity, man. Oh, wait, I'm retarded. I put minus 1, but it's plus 1. Okay, now. Oh! Why am I so stupid? Yeah, so now it works. Yeah. And actually, let's check the angle. Is there an angle? Yeah, here. Well, the angle is definitely not correct. Bro, can you piss off, please? It's 45 only. What the hell? Okay. Oh, yeah, because I got fucking pranked. This is not 1. This is minus 1. Ay, 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 man. This is minus. This is minus. So that means that q is actually 3. Well, I pranked myself, to be fair. Ay, man. Yeah, but once again, that does not work at all. What the hell? Oh, because in mine is started once again. Yeah, now it works because I'm not interested in fucking 315. Oh, fucking. Yeah, it's 90 plus 45. 90 plus 45, that 135, yeah. So this is the correct solution. So maybe if I was not retarded, I would get it on the first try, but unfortunately, this reset the streak. Ay, 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 ay. Zero. Tragedy. 4, 7. So now let's solve the second, but maybe correctly. That would be nice. So that's okay, is tangent pi over 3. Oh, actually, no. This is a good opportunity to actually rewrite the whole table. So we have 0, pi over 6, pi over 4, pi over 3, pi over 2, pi, 3 halves of pi, and finally 2 pi. We have sine function 0, 1 half, square root of 2 over 2, square root of 3 over 2, 1, 0, minus 1, 0. We have cosine 0, square root of 3 over 2. Sorry, what the hell is that 2? Square root of 2 over 2, 1 half, 0, minus 1, 0, 1. We have tangent 0, square root of 3 over 3, 1, square root of 3, not defined, 0, not defined, 0. And finally we have the cotangent, not defined, square root of 3, 1, square root of 3 over 3, 0, not defined, 0, not defined. So this is square root of 3 over 3. No, that's cotangent, I'm retarded, bro. Let's quickly check the table. Whether it's correct or not. 1 half square root, yeah, 1, 1 square root of 3 over 3, square root of 2 over 2, 1 half, 0, yeah, 0, square root, 1 square root of 3, no. 1 square, yeah. So it's correct. Square root of 3. So we end up with y equals square root of 3x plus q, which is not ideal, to be honest. And now we just input the point, which is, actually let me copy it over. And just input that in there. So we get 2 equals square root of 3 plus q. Oh god. So we get u is equal to 2 minus square root of 3, which I don't know if there is a good way to calculate this. Which leads us to y is equal to square root of 3 times what do you mean, x? The x is not under the square root, plus 2 minus square root of 3. So let's quickly check that shit. We get y is equal to square root, what the hell? Square root of 3x plus 2 minus square root 3. What's the angle again? It was the angle is 60 degrees. Let's quickly check that. The first good sign is that it's going through the correct point. Tools. 60 degrees. Wow. Let's actually check first with the book. That's a 4, 4, 4, 4, 6, 4, 7 actually. 4, 7. Eh. Doesn't seem to be 4, 7. Oh. Yeah, okay. Yeah, that's correct. And minus x. This is correct. The streak is back, guys. Streak of 1. Okay. Come on, come on. Bro, I don't want to do. Okay, let's do one more. 4, 9. 4, 9. So once again, the directional equation. And we are trying to do directional equation of P1. It goes through the point A, minus 3, 3. And it is... this is P1, this is P2, and P2 is actually 1, 1. Okay, sorry. They write it so weird, it confuses me. 1, 1, 4, 2. Okay, so basically what we need to do now is... Wait, how do you find the angle between two? Wasn't it like cosine alpha is u times v over something like this? I quickly check. Kurla pilla, man. Kurla pilla. Oh, that's actually quite smart. Okay. So what I need to do, I wonder if I can. Yeah. Okay. So I don't even need to do this shit. I just take P2, which is 1, 1, and C 4 halves for 2. What the fuck? And I need to get the. Let's get the general equation. So we get is C minus B, which is gonna be 3 1 minus 2. Bro, my focus is cooked. Ah, okay. 2 minus 1 is 1. Then we get the normalized vector, which is, let's go, minus 1 and 3. I'll just pop it into the, so we get minus x plus 3y plus c equals 0. Do I even need to solve for, hold on a minute. I don't even need to, nah, maybe I do. Yeah, I do need to solve that, okay. So now we solve for c, so c is gonna be, let's do 1, 1 for example, so we have minus 1 plus 3 plus c equals 0. We get c, c is equal to minus 2, so we get the minus x plus 3y minus 2 is equal to 0. And now we need to actually get the point where the line intersects the y-axis, which we do by just putting 0 here. So we get 3y minus 2 is equal to 0. So we get that y is equal to 2/3. So let's make that py is 0 2/3. So we know now where this intersects 0, and with that we can just pop it into the equals q, because this is, what the fuck, this is the q, the 2/3. So we end up with, and the k and y we can just input from a random point, which will do the b. So we end up with x equals, sorry, 1 equals k plus 2/3. We subtract 2/3 and we have k equals 1 third. And now we need to do tangent or arctangent of this. Let me just quickly do that. Of 1/3 in radians, please. Ooh. Okay, that's not good. It is not good at all. No. I must have made a mistake somewhere because that is not good. Okay, let's pull up GeoGebra. We have 2 points. B plus. I could probably pull up the GeoGebra, but oh, come on. 1, 1 and C 4, 2 is actually correct. 9 ping pong. No. We get a point. Yeah, give me the coordinates though. Yeah, so it's 2/3. What's the angle? I messed up the angle calculation then. No, I didn't. What the hell?